Okay, so in this section we are going to graph basic sine and cosine functions. There are the two of the three primary trig functions. The next one will be tangent. Tangent is a little bit different, so we're going to deal with that in a different on a different section after this. All right, the very first thing is that we need to have go back to the sine and cosine and a unit circle. The unit circle is radius 1, if you remember. Suppose we have a coordinate right here on the circumference of the circle, and that coordinate is x comma y, and we want to come up with all the trig ratios of that standard position angle. Okay, so here it is. Let's call that theta, and we know that this is x, we know that this is y. So what is x? What is the, let's write up the sine of theta. What is that? That is opposite, so it would be y over hypotenuse. Remember, hypotenuse is 1 because the radius is 1. That's a unit circle, so it would be y over 1 or y. What is cos of theta? That would be adjacent over hypotenuse, will be x. So it turns out that the coordinate x, y on a unit circle is cos theta and sine theta. That's basically it. And now you have to get used to using that. So as x goes through, so the value of x changes around the unit circle, you notice that the y value changes, and you're going to get different coordinates depending on which quadrant you are on, and therefore is going to create this graph, the function graph that we're going to deal with next. Okay, so let's go ahead and graph the function y equal to sine of x. And we're going to use a table of values, okay? And I'm going to use radiant measure so that you can see it. I have the unit unit circle here set up, and this graph is already set up for you. That's the graph of the sine theta, but you don't know what that is yet. Okay, I'm just going to explain to you how this is being created. So as we put in values of these values for x, notice that it's just basically a table of values. 0 for x, what is sine of 0, and the answer will be 0. Simple as that. As you go through this, sine of pi over 6, you punch in pi over 6 in here. Sine of pi over 6 is 1/2. And then you keep doing that, you notice that the values that you will get for each of these will be a little bit different, but basically you're going to create these coordinates like that. Okay, like that and like that. All right, simple as that. And pi over 3 was 0.87. Yeah, I could have put in pi over 4 as well. Actually, you know what, let's do that. So here are the first values between 0 and pi over 2, or 90 degrees. And notice that these coordinates, they just basically, as you get them, you basically you see this pattern that's being created. What I did, I put in the unit circle for you and mapping each of these coordinates. So if you have this coordinate here, and that coordinate is pi over 4, the pi over 4, when you punch that in, you will end up getting sine of this value will end up being pi over 4 comma 0.71. Okay, that's this value right there on the coordinate. This coordinate right there, which you can see, that coordinate is the for x value, because you're looking at the theta, that's the pi over 2, which is 90 degrees, and the value of y is 1, which is right here. Okay, so it's mapping each one of these as you go through the coordinates, or sorry, around the circumference of the circle. As you rotate through, these coordinates will map as well, if you want to look at it like that. Okay, and sure enough, you will get this curve, which is actually very symmetric and is periodical. Notice that it's coming down to the negative part of the x values and it's continuing after 2 pi. I did one full circle where it starts at 0, 0, goes around up and coming down to -1, and then comes back and hits 0 for x again, and that we call that a one full cycle. We're going to talk about the mechanics of the graph, okay? But this is a typical graph of y equal to sine of x. And remember that x is the angle, okay? That is the angle that you're dealing with. That is the angle, okay? Sometimes they call them x, sometimes they call them theta, alpha, doesn't matter, but that is the angle, and it's the standard position angle that you're using. But in terms of the function graph, you just plug it in, and this is the pattern that you're gonna create. Couple of things about this graph. Number one is that be aware that there's a maximum value here. So what is the maximum value of this graph? The maximum value is at 1. The minimum value is down here, which is -1. And that's true because sine function doesn't go above 1 or below -1, the basic, the parent sine function, okay? And then what is the full cycle? We call that a period of the function. For the trigonometric functions, they have a period because it's a periodic graph, periodic function. So what it means is that the distance from where you start here, let's start up with from here where it starts and ends on the x-axis. So what is this distance, complete distance from there to there? Well, that is 2 pi. Okay, for the basic function y equal to sine x, the period of the function 2 pi, that means it will repeat itself over and over, and every time that you go through a 2 pi interval, you'll get the same shape graph. So basically, we're using the same concept for the next trig function, cosine of x. So this function, same idea, we use x values. We can use the unit circle again. I just didn't want to repeat that again. You just go through and plug in the values from 0 to 2 pi. I stopped after pi over 2, but it can continue. And I use these exact values, just 30 degrees, 45 degrees, 60 degrees, and 90 degrees, okay? These are the equivalent radians measure of those values. All right, as you plug it in, you notice that you get these coordinates, and simple as that. So when x is 0 degrees, you get value of 1, which is right here, okay? And pi over 6, this is right there, and the coordinate right there is 8, which is 0.87. Great. As you go through this, you notice that each of these coordinates will map until you hit 0 again, which is pi over 2. And if that's the case, when angle is 90 degrees, the value of cosine function will be 0. Notice again, this graph is also periodical. It has a minimum and maximum value. So this is your minimum value. Here is -1. Minimum value of the function, maximum value of the function, which is, there are two of them, but they're same, doesn't matter. So the maximum value will be is 1, okay? And the minimum happens when you're at pi, when x is at pi, so this is at pi happens. All right, the maximum happens twice at x equal to 0. This is at x equal to 0 and at x equals to 2 pi. Okay, and it is periodical, so that means that the period of this function as well is 2 pi, okay, because where you start and when you end is the same. So here it is, the period is 2 pi, and this is the basic parent cosine function. It repeats itself. Notice that I stopped the values of x that would mean negative. We could have a negative angle. Remember, the rotation becomes a clockwise rotation if you go to negative, but still this graph repeats itself. So we can go ahead on Desmos and look at what's happening. Okay, the first graph, y equal to sine of x, I just punched that in, y equal to sine of x, simple as that, and you get this wave-like graph that is coming in, and notice that is exactly matching what we talked about, 0 at 0, pi over 2, when x is pi over 2, the value of the function is 1, and then it repeats itself, right? This is your one period between 0 and 2 pi, but it repeats itself again. Okay, and it repeats itself again. By the way, the period of a function, you can actually match any 2 points that they come back to the original. So if I start here at the top and I go around and come back up, that would give me 1 period, 1 full cycle. That's what it means. And notice that this piece graph right here, if I choose that, that's actually equivalent to the cosine function, which is what they are actually. Sine and cosine function, they are related to each other by pi over 2 shift. We're going to talk about that. Look at what happens when we deal with the cosine, the blue graph. Now I'm going to leave, actually let me stop the sine first. So the cosine function, it starts at 1 and then comes down and hits pi over 2, then it drops down to pi to -1 at pi. So cos of pi, if you punch in a calculator, you get -1. And then as you increase the value again, so when you go to be between pi and 3 pi over 2, the value of the y value becomes larger and larger until it hits 0, and it continues and goes to up to maximum of 1 at 2 pi. That's a full cycle again. Notice that as the period of this function is 2 pi as well. Now look what happens when we have put them together is basically you get these two graphs that are being, the two waves, they're being shifted. One is shifted to the other one. So if I notice the shift here between the cosine and the sine function, sine is the red, is right here, cosine is there. So if I shift the sine function by pi over 2 to the left, I'll get the cosine function. And that's exactly what we can do to do that. But that's another section we're going to deal with that. All right.